Hello, my name is Colton Degen. I'm recording this for my Indigenous Youth Data Analytics and Artificial Intelligence internship. Our problem is designing a model because manual identifying cyber attacks would be a near impossible task across an entire network for an organization. So implementing a model is much more effective to go through all this data and identify what is harmless and what is a malicious attack. The dataset is a series of 8 datasets that are provided by the Canadian Institute for Cybersecurity. It has 79 columns, and it combined has nearly 3 million rows, which is a lot of data. Our target is the label column, as it shows what is harmless and what is a cyber attack. On to cleaning. I combined them all into one data set, and then that combined data set, I dropped all duplicates, which removed a lot of rows. And then because Colab couldn't handle the size of each variable, I downsized it from 64 to 32, which I don't believe compromises the data at all. And then I dropped all null values, which there weren't any to begin with, so that was good. And then I changed the columns to get rid of the white spaces at the front, because it was annoying. And then I separated all of the 78 columns into one, and then I separated the last label column into another. And then I wanted to change the label column to something that would be a binary choice or identifier. So anything that was benign stays as benign, and all else is an attack or malicious activity. And then this removes any invalid values that would mess up, that would throw an error. And then I recombine them, and then I split them again. You can see I also printed out what the ratio of benign and attacks. And then there's the label encoder, which turns the Y value into either a 1 or a 0, I believe. And then we go on to splitting the data into training and testing, which I went for 80% training data and 20% is for testing. And then this is for building the model. First is here's compile it. I went with a learning rate of 0.01. And then here's with the actual training. I went with 10 iterations at a batch size of 1024. This dataset is known as an artificial neural network, which handles complex relationships between data. And then we move on to testing it. as you can see across the board, it got 98%. But specifically, the recall value is 98. Recall is very important because that is the number of correct positive values, positive attacks, the number of attacks it was able to correctly identify as attacks, which can be viewed in the confusion matrix. You can see the majority of attacks it was able to recognize as attacks. Coming to the end here, I do think that this model obviously performed very well. I found that very surprising. In terms of strength, I think having it being a binary value is kind of a double-edged sword, as there's less confusion. It's less likely to it's a binary choice, so it's less likely to misidentify something. Although I do think that in a real-world environment, it would be very restrictive to simply have a yes or no as to how if this activity is dangerous. I think it works better if there's a certain degree of danger or suspicion, because safety and convenience are inversely proportional. So it's really about how valuable the data is that you want to keep safe using this model. And that's about it. Thank you.